Welcome back to Differential Geometry. Today we'll be talking about the tangent map of an isometry, which corresponds to section 3.2. So we're going to start with a reminder of the definition of a tangent map. Let f Rn to Rm be a mapping. If v is a tangent vector to Rn at P, let f star v be the initial velocity of the curve t to f of P plus Tv. This is called a tangent map. But if f is an isometry of R3, this map is simplified. So this leads into the next theorem, which tells you how it can be simplified. Okay, so let f be an isometry of R3 with orthogonal part C. Then f star of v sub p is equal to cv sub f of p, or at the point f of p, for all tangent vectors v sub p to R3. Okay, to prove this, so we can write f is equal to tc, where t is a translation and c is the orthogonal part. T equals, well, t is a translation by some point A in R3. Or in other words, so f of A is equal to A plus C of P. Okay, if v sub p is a tangent vector to R3, then f star of v sub p is the initial velocity. Of the curve t mapping to f of p plus tv. And this is as per the definition above that we started with. So using the linearity of c, we can then write the following few steps. F of p plus tv is equal to, well, first it's tc of p plus tv, which is by the above discussion. tv. And this is the next step is by linearity. The t of c of p plus t c of b. Okay, so this is a c and this is a c, because I know it's going to be confusing just looking at that. And then we can then write that this is equal to the vector A, or the point A, or vector A plus C of P plus T C of V, which is equal to F of P plus T C of V Okay, and finally, this is equal to CV at the point f of p. And this is by definition. So, and that completes this proof. Okay, I'm going to move on. And this result has a corollary, and that I'm also going to prove. And that is that isometries preserve dot products of tangent vectors. That is, if v sub p and w sub p are tangent vectors out of R3, or to R3, and vectors to R3 at the same point. That same point is P. Well, and assuming that F is an isometry, and F is an isometry, then F star of V sub P dotted with F star of W sub P is equal to V sub P dotted with W sub P. Okay, so to prove this, we're going to let C be the orthogonal part of F. Part of F, and we recall that C, being an orthogonal transformation, preserves dot products in R3. Okay? So using the past theorem, the one we just proved, F star of V sub P dot F star of W sub P is equal to, well, CV sub F of P dotted with CW sub F of P, which is equal to CV dotted with CW by definition, which is equal to V dotted with W, and this is because dot products are preserved by orthogonal transformations, and this is equal to V sub P dotted with W sub P, and this is again by definition. Okay, so most of this proof just follows from the past theorem. So in conclusion, so dot products are preserved, but that also means we get a bunch of other concepts for free. So we get, for example, norm and orthogonality for free, just because they're derived from dot products. And that is where I'm going to end this presentation. Thanks for listening.